Sharma, Assistant Professor, AC Department. Today I am going to start with the next topic of the subject, that is wireless and mobile communication. The topic of today's lecture is equalization. So, in this we will going to discuss channel estimation, equalization techniques, that is different types of filters or equalizers that are used to perform the equalization procedure. Like first one is transversal filter, adaptive equalizers, zero forcing equalizer and decision feedback equalizer. So, first we will see what is equalizer. So, equalizer is basically when we are transmitting a signal, it will travel over a channel. At the channel, it will be affected by a noise, that is additive wide Gaussian noise. Now, let us say we have transmitted this particular signal, this will travel, this is at the transmitter side, this is t versus x t versus t graph, this is the channel. It will going to travel over this particular channel, this will be added by a additive wide Gaussian noise. Now, this signal, that is y t, this will be transmitted through this particular channel, it will be added at the additive wide Gaussian noise, then it will be affected. So, what will happen due to this noise, the characteristics of the signal will change, which means pulse shape will be changed. So, what the equalizer will do at the receiver side, it will equalize this particular pulse, which will going to remove the signal, since this additive wide Gaussian noise, because when we are doing the mathematical analysis, when we are considering the power spectral density of this AWGN noise, it will be n naught by 2 and that is also additive in nature. So, that can be subtracted easily from the received signal, so that we can get this x t signal. So, what the equalizer will do, it will going to change this received waveform, remove this particular noise, and we are going to receive this at the output of the receiver, we are going to receive that what we have transmitted. So, it has equalized the pulse, means pulse shaping is corrected. So, that is the channel, that is the equalization pattern. So, first we will see the channel estimation technique. So, channel estimation is an autoregressive process that may be performed with a number of iterations. Now, number of iterations means, like let us say it in first go it will be k is equals to 1. So, that is a kind of loop, then in the second go k will be is equals to 2, k is equals to 3. So, every time the maximum value of k can be taken as 15 in case of carrier sense multiple access, which means that how many times the packet will be retransmitted. So, that is the channel estimation process. So, an autoregressive model specifies that the output variable depends linearly on its own previous values or some known values. So, channel estimation is the estimation of the channel impulse response, that is CIR, at the receiver. So, there are three different techniques that are used for channel estimation, like first one is CSI based, where pilot or training sequence are based. Now, what is pilot? There is a pilot carrier which will be used at the transmitter side or the receiver side for the purpose of coherence modulation. Coherence modulation is the thing where same carrier signal is used at the transmitter and receiver side, so that it will be demodulated perfectly for the synchronous demodulation. Now, second is the blind, that is statistical data or prior knowledge based. It is based on the statistical data prior knowledge, which means it what prior knowledge it is having for this particular type of data. Now, next is the semi blind, where different blind technique is there. So, these are the three different techniques for channel estimation technique. Now, channel impulse response estimation basic is there. So, in general channel processes are wide sense stationary, that is WSS. Conceptually, on a stationary wireless channel, if an impulse is transmitted, then multiple delayed versions of the impulses will be received at the receiver at different instants of time. So, in this case, like these impulses are non-correlated to each other, means coherence does not exist between the different signals that are received. With reducing amplitudes with time, they are just delayed samples, and hence a differential equation with coefficient values can be correlated with this concept. So, FIR filter model will be adopted. FIR means finite impulse response. Now, what is impulse response of a particular system? Whenever channel is there, channel is having their own transfer function. Now, that transfer function is the impulse function. So, whenever the signal, whatever signal is there, like this is the x n, this is channel and this is the receiver, that is y n. Now, this channel is having a transfer function h n. H n should have a function that is impulse function. So, whenever any kind of signal is passed through this particular channel, the output will be the channel impulse response, and that is when it is passed through the impulse function. So, in this case finite impulse response filters are used. So, the impulse response is time varying and can be represented as y n is equals to h e n, then it will be multiplied by x n plus w n. Now, what is w n? W n is nothing, it is noise, and mostly it is additive wide Gaussian noise. When we are doing the mathematical analysis, then w n can also be written as n naught by 2 in frequency domain, power spectral density. Now, n naught is the noise at t is equals to 0. So, next state estimation is based on h n plus 1, which is equals to a h n plus w n. Now, w n is again it is the noise, where is the coefficient value to estimate the next channel state. Now, next is comparison between different channel estimation techniques, like first one is the training sequence based, another is the blind method. In case of this training sequence, the sequences known to the receiver are embedded into the frame and then it is sent over the channel. So, whatever sequences that we know to the receiver, these are embedded into the frame, which means that like in case of blind state, there is no training sequence, whatever prior knowledge or whenever the new signal will be received, it will be estimation, channel estimation is based on the prior knowledge, whatever prior knowledge is there, it is based on that thing. But in case of training sequence, a known sequence will be used to train the particular model. It is very easy and very popular, it consumes higher bandwidth, since the sequence that we already know is of higher bit is having higher bits as compared to the blind method. It is computationally, it is not too intensive. The two major drawback is there, it is a waste of information, bandwidth. In case of blind method, the major drawback is that it is hard to implement on the real time system. So, that is the case for blind method. Now, next is equalization techniques. So, the term equalization can be used to describe any circuit or signal processing operation that minimizes the inter-symbol to interference ratio, inter-symbol interference ISI. Then the purpose of an equalizer is to reduce ISI as much as possible to minimize the probability of wrong decisions. So, the ideal response requires an equalizer that responds as the inverse of the channel. Now, equalization is the reversal of distortion that is incurred by a signal that is transmitted through a particular channel. So, that is the main concept behind this equalization. An equalizer is an inverse channel filter to mitigate the unpredicted channel problem. Like you can see, in case of this equalization technique, there are different types of equalizers that are used. Like this is the signal that has been received, it will be applied to this distortion to a filter which is having a transfer function given by this H f, it is been applied to this one. Now, this is applied to a channel. At this channel, an additive noise will be there, which is given by this W n. This is additive white Gaussian noise. Then it is applied to this R n. This is an equalizer, that is H inverse f S dash n. Then the equation will be R n is equals to H n multiplied by S n plus W n. So, that is the main model of this equalization technique. Now, the channel equalization concept in a digital communication system using a match filter and decision making. Now, this is a very simple diagram that how the equalization will be made. So, equalization is used to equalize the pulse shape. So, at the receiver side, like you can see that this is the received signal, it is passed through a channel, then a matched filter is there. So, there is a matched filter, another is the optimum receiver filter. So, this filter is used at the either this or this. So, the transfer function of performs better for this matched filter as compared to the optimum receive filter. Now, this is applied to a decision device where a threshold value is selected. Now, this particular threshold value will provide a decision, it will going to decide that whether it has a value greater than a particular value or it will be less than to that particular value. Then an estimated version of this transmitted signal is there, that is S dash n. Now, next one is the transversal filter. Now, this is essentially a tapped delay line which the feed forward taps, forming a finite impulse response filter. Now, each delay element delays the input signal as it propagates through the particular filter. So, that is the transverse filter response. So, the delayed version of this signal, that is given by this particular formula, that is y t minus k t, where k is equals to 1 to up to 3 are the tap coefficients and t is the period by which the signals is delayed and it is tapped along the delay line. Then the output of these tap coefficients are summed to generate the filter output. So, this is how we have to select the particular data. Now, the integrated filter transfer functions can be adaptively adjusted by changing the coefficients, that is C naught up to C k of its tap weights. Now, this particular adjusting the tap weights, let us adapt to zeros in the overall transfer characteristics of the filter to various frequencies and it is implemented using different filter characteristics such as notch filter, band pass filter, then there will be a low pass filter or a band reject filter. Now, it is passed through, it is a linear method of equalization that we have seen over here. So, this is a transversal filter. So, this is the diagram of the transversal filter and multiplierless transversal filter. Now, you can see that here the weight functions are act as an multiplier, means this particular value will be multiplied by W n. Now, this is W n 1, this is W n 2, this is W n minus n. These are passed through different delays and added together to get a approximated value of the received signal. In case of multiplierless, these values are added together, because we have converted this multiplier to addition by using a log value, which means that whatever multiplication is there, when it is passed through a log filter, it will be converted to addition. So, this is how the multiplierless transversal filter looks like. So, this is how the addition will be there, this is log to linear. So, once we have converted this signal from linear to log, which means from multiplication to addition. So, before adding together, we have to convert this log signal again to the multiplication factor, so that the quality of the signal will be maintained. Then this is summed up together to get the estimated value of the signal that it has been received. So, these two are the same thing, but in this case we have used this addition as compared to the multiplication, but there are two more additional blocks are required, like first one is linear to log, another one is log to linear. So, zero forcing equalizer. So, zero forcing equalizer refers to a form of linear equalization algorithm that is used in the communication system, which applies the inverse of the frequency response of the channel. Now, the name zero forcing corresponds to bringing down the intersymbol interference ISI to 0 is in a non-free case. So, this will be useful when ISI is significant compared to the noise. So, if the channel response for a particular channel is H s, then input signal is multiplied by the reciprocal of it, which means that how we have to select the zero forcing value. Like this is HF, this is XF, this is YF. Now, in case of zero forcing equalizer at the receiver side, we have to use a filter which is having transfer function given by 1 upon HF, that will going to equalize the value whatever whichever it will be changed due to the effect of noise. So, thus the combination of channel and the equalizer gives a flat frequency response and linear phase. So, FF and CF is equals to 1. Now, next is the adaptive equalizer. So, in case of this adaptive equalizer, it is a non-linear equalizer that automatically adapts to time varying properties of the communication channel. So, this is the received signal, that is SN, it is applied to this channel. Through this particular channel, it will be applied to this weight functions, where different weighting functions are there. Then this is applied to this transversal filter. Now, output of this particular tab weights will be S dash n, then this is applied to a matched filter. This is the decision device, and here there is a particular kind of decision making device is there, which is having its own threshold value. So, it will going to decide that whether it is greater than the particular value or it is less than, then at the output there will be S dash n. So, adaptive equalizer can control the tab weights on the basis of estimated channel coefficients from the received known training sequences. So, whatever training sequence that we have known already, it will going to change the value of this tab weights, so that the good quality of signal will be received. Now, this is the decision feedback equalizer. Now, in this case, it augments a linear equalizer by adding a filtered version of the previous symbol estimates to the original filter output. Like this is the received signal, this is passed, this is transmitted signal passed through a channel. Now, this is the received signal. Now, here we have to use a particular kind of equalizer which have their own tab weights, which is connected in the forward filter, that is feed forward. Then there is a matched filter which has its own transfer function. Then it will be applied to a decision device. Now, this decision device and matched filter will provide a delay of delta. Now, this delta function is calculated over here, and then in the feedback path it will going to calculate the value of the tab weights, that is W. Now, this is the first estimation of the transmitted signal, this is the second estimation of the transmitted signal, you can say the integrated version of the transmitted signal. Now, next is the least square and least mean square algorithm. Now, least square means that the overall solution minimizes the sum of squares of error made in the results of every single equation. So, this is the diagram of LSM method, that is least LMS method, least mean square algorithm. Now, in this is the input signal, it is applied to a filter whose transfer function is given by H n. Then this is y n, that it is the output, it will going to travel over the channel which is affected by this noise W n. Now, this W n, the output will be given as D n, this is applied to this particular signal. So, here there is y cap n, that is the estimated value of the transmitted signal. Then here there is an h cap n. Now, what is h cap n? This is again an equalizer which is the predicted value of this H n, and its value has to be is being changed, which means it is variable adaptive filter. It is kind of adaptive filter whose transfer function resembles with this H n. Now, this is applied as an error to this adaptive filter output error, and then it is applied to this noise signal. Now, the LS, the least square and the least mean square algorithms represent the regression processes to adapt the system continuously. So, whatever system we have seen, it will going to adapt continuously depending on the value of least square or least mean square. Now, least mean square algorithms are a class of adaptive filters that are used to mimic a desired filter by finding the filter coefficients that relate to producing the LMS of the error signal. So, difference between the desired and the actual signals are there. So, it is a stochastic gradient descent method in which the filter is adaptive based on the error that at the current time it is been shown over here. So, this is the least mean square method. Now, in this we have seen different types of equalization techniques. So, equalization is basically when we want to reduce the effect of the noise at the channel. So, whatever signal that we have received, like this is the transmitter, here there is a pulse of the signal will be there, there is a channel, at this particular channel there is an adder is there. So, which will going to add this AWGN signal. Now, this signal which we have received will be a distorted version because the effect of this noise. Now, then it is passed through different types of equalizers that we have already seen. So, this equalizer will going to change the shape of the pulse which is somewhat like this one. So, this is the received signal pulse. So, this is passed through an equalizer. So, this is how the channel equalization concept in a digital communication system using the match filter and a decision making device. Now, what this decision making is all about? It has a positive value, it has a negative value, it has to check that whether whatever signal that we have received after this multiplier whether it has crossed the decision value or whether it has not crossed the decision value. So, this is how the signal will be passed through this particular device, and then here a estimated value will be there. So, S n at the output it will be passed through this S dash n. Then there are different comparisons are shown, that whether the training sequence is there or the blind method, whether the channel estimation is based on training sequence. In case of training sequence, the bits that has to be transmitted is known already. So, sequence known, the receiver are embedded into the frame and then these are sent over the channel. So, whatever we have transmitted, we have already known the training sequence. We have to train the equalization model. It is very easy, but the bit rate is quite high, which means the higher bandwidth is required, since we have already known the bits. Secondly, computationally it is not too intensive, and it is extremely intensive method in case of blind method, because since we do not know whatever bits that we are having is what we have transmitted, we do not know it already. So, we have to see the blind method. It is much more intensive, it requires much attention as compared to the training sequence, because in training sequence the bits are already known. In case of this blind method, the bits are not known. The major drawback is that it is a waste of information bandwidth, and in this case it is hard to implement on real time system. So, in case of real time system, why we cannot implement this blind method? Since we do not know that whatever what is the training sequence, how we are going to train the particular model for the channel estimation. So, it requires large mathematical operation, hit and trial, large number of hit and trials are there. So, real time system modeling is not possible with this blind method. It is only possible with the training sequence, but it comes with a drawback of higher bandwidth. Then we have seen the different types of equalization techniques, where we have to minimize the intersymbol interference problem. That is, what is intersymbol interference problem? Like more than one transmitters are transmitting a single signal, then it has the waveform will going to disperse. Now, due to this dispersion of nature, it may be possible that first version of the signal, the second version of the signal, then it will collide together. So, that means this will be overlap together, that will cause the loss of information. So, that is the main drawback of equalization technique. Now, these are the transversal filter. Then we have seen zero forcing equalizer, where the equalizer transfer function will be inverse of whatever we have used at the transmitter side. So, these are the references that you can consider for this particular topic. Thank you.